Hey YouTube, it is a fine day today and ideal weather conditions conducive to excellent and maximum solar generation. Now, you must always have a reason for taking some action. Okay, so what this means is that why did I do this? Well, number one, the situation with load shedding has become untenable, and load shedding now has become part of our daily lives, and it does influence and impact our lives, right, negatively. But at the same time, we have to look at the positive side of it. Every cloud has a silver lining, or so they say. And here in South Africa, in Afrikaans, we have a saying that goes, "A boer maak 'n plan." And what we are doing as South Africans is we are innovating out of our constraint, and we are moving towards renewable energy at quite a fast rate. I think the country that moved probably faster than us was Vietnam, when they also had a power crisis, and the government encouraged everybody who could afford it to install rooftop solar, and they were able to resolve their issue with their power crisis issue. What else? So whether you're an Eskom direct customer or you buying your power through your municipality, I'm sure you probably would have had a scenario where your bill was incorrect, and that can create a problem depending on your cash flow, right? Depending on your income, and if your bill suddenly becomes 3 times more or 4 times more, and this has happened in the past, I know of people who have mentioned this, then perhaps that's your reason for wanting to move off grid. Another reason could be that you want to become self-sufficient, where you paying off your own asset and you're producing your own electricity. That could also be a reason. So what I've done is I've replaced all the solar panels, and previously I had about 5 kilowatts of solar panels on the roof, and now I've got about 11 kilowatts or 12 kilowatts of solar panels. So altogether I've got 26 panels. We've got 14 facing north, and we've got 12 facing west. And I did some research before I decided to install west facing string, and whether you go with east or west, you are going to lose about 10% of your generation per day. So you will encounter challenges. For example, there's a chimney on the north facing roof there, and what that means is the consequence of that is that in the afternoon, when the sun is about to set, then there is some shading there that occurs on the panels just adjacent to that chimney. But it's not, I am losing out some generation, but it's not significant, right? In the previous setup, I was not completely off grid, so I was still relying on Eskom quite a bit, especially for water heating in the mornings, and for cooking as well. Whereas the new system is, I would say, 85 to 90% off grid. Okay, and then in the previous setup, we also had 5 kilowatt hours of storage, and we had a 5 kilowatt inverter. Now we have a 12 kilowatt 3-phase inverter with 15 kilowatt hours of storage and 12 kilowatt of panels. And let's look at some of the capabilities and the stats that I've gathered so far. This new system will allow us to generate between 68 kilowatt hours to 70 kilowatt hours per day, and this is more during spring and summer. Peak generation is between 10 to 11 kilowatts. The highest generation so far, this was within a day, was 60 kilowatt hours. And then let's talk about some of the panels that we've got here. We've got 14 times 545 watt panels on the north. So the highest output panels is on the north, and towards the west here we've got 12 times 460 watt panels. And you may ask me, why did I go for 460? Because when I evaluate the cost, I always want to try to minimize the cost, and if I'm able to procure a panel that is cheaper, then I have sufficient space, so I decided to go for the cheaper panel, because my payback period then is shorter. And what you got to look at the cost per watt panel. So if you look at it now, you're paying about between 5 and 6 rand per watt for these new panels. The good news is that the cost of the solar panels are dropping. So try and get the highest output panels that you are able to procure. So the nice thing is that recently with the new system, I've been monitoring the performance of it, and what I noticed it, and I wasn't really surprised, but because we've now got we've got a 3-phase inverter. It means that what I've done is I've moved the entire property onto that 3-phase inverter. What I mean is that having a bi-directional inverter, the inverter is capable of measuring the entire demand for the property. And in order for me to do that, just bear in mind that my previous system was a single phase inverter, so I had to convert my house's distribution board. Although there were 3 phases coming into the DB, I was only using 1 phase, and only 1 phase was connected to the inverter because it's a 3-phase inverter. But converting everything to 3-phase was a massive task, because my ESCOM feed is at my boundary wall, which was going to be about 45 meters away from where the inverter was going to be installed. That means that I needed to run the CT coil. The CT coil is called a current transformer. What the current transformer does is that it clamps onto your feed, your ESCOM feeds coming in. So for 3-phase, you have 3 cables coming in, and the CT coil goes and clamps around each of them. So you have 3 CT coils. So what it meant that was I had to trench and uplift paving in order to run and extend that CT coil from the inverter all the way to the ESCOM feed at the boundary. And that was a big task, because number one, how do you extend that CT coil cable? It's not straightforward. So what I used was a Cat5e cable, and I use a cable that is protected or shielded. So shielded meaning it has a foil around the cable, and it protects it from interference. So we had to run conduits, we had to do trenching, uplift paving, run the 3 cables through the conduit and into the ESCOM feed. And that took a while to do all the trenching and getting everything done, which we'll show you just now how everything is done. So far in winter, I'm using about 50% of my power consumption exclusively in the morning. And what is the biggest consumer of all of that energy? It is nothing other than the water heater or the geyser. Because we have 3 geysers running in the mornings to heat up water for morning showers and so on and so forth, and other ablutions, 50% of that is consumed in the morning. So water heating in winter is challenging. The other thing that is a big consumer of energy is space heating. So oil heaters, bar heaters. Fortunately, I was able to use my fireplaces. So I've got 2 fireplaces, and that saved me a significant amount of money by not using oil heater. But unfortunately, I ran out of wood because I was running 2 fireplaces for the first time. Normally I only run 1 fireplace. So as far as space heating goes, the main dwelling did not use a heater for winter. However, the other 2 dwellings, there's no fireplaces there, so they had to use some sort of space heating, and that is another big consumer of electricity, especially in winter. So take a look at these charts here, and you can see the peak demand of electricity, particularly in the morning. Now, when you're looking at an off-grid system or going off-grid, you need to have alternatives for those peaks, for that peak demand. So with my system, the EVT system here, which is heating the water, which was installed in 2018, that works pretty well. But in winter, we have to supplement it with electricity. Okay, so that sums up what we've done on the roof, but what it does mean is that now I am heavily reliant on the sunshine. When it's a cloudy day, I have to still rely on my utility for energy up until after my battery storage is depleted. The battery storage that I have is capable of lasting me the entire night, but having a hybrid bidirectional inverter and supplementing the entire property, it means that I'm sharing my storage with the other dwellings that do not have any storage. If somebody boils a kettle at 8 p.m. and we have utility that is still connected to the inverter and we have battery available, then that demand is going to be drawn from the battery and not pulled from ESCOM. So that's how the bidirectional inverter works. The advantage of it is that if there's excess solar capacity here, if we have a fine day like this, and if the main dwelling is not utilizing the maximum power, then the other two dwellings can use the power from here, the excess solar capacity, and not purchase from ESCOM. Another key difference is that I am not exporting to ESCOM anymore. With the previous setup, the Goodwear was also a hybrid grid-tied inverter, and it was capable of exporting to the grid, and occasionally I was exporting to the grid, and I had a reason for that because one of the dwellings shared the same phase that the main dwelling was on. Then instead of buying from ESCOM, I was exporting about 1,000 watts, and if that dwelling then required that, it would then only pull what it required from ESCOM. So that was the advantage, but that was because I didn't have the CT coil at the feed, at the ESCOM feed. Whereas with this setup now, I've completely minimized any waste. Whatever I'm capable of generating, I am consuming. And towards the afternoon, where I have excess generation because my battery bank could probably take in one more battery, and then with that one more battery, when the sun has reached its zenith and is now heading towards the west to sunset, that's when this western string is gonna start producing a fair amount of power. So if I have one more battery, then I can store the energy in that battery and use that overnight. Let's take a look now at the inverter setup. So here we have the new setup. This wall, excuse all the soiling and the holes. There's a couple of roll bolts. The rolls are still in the wall because yeah, we weren't able to get them out anyway. So those roll bolts are from the old Devil 2000 watt inverter that we installed in 2015. And then after that, this wall carried the Goodway inverter, and now it's carrying the Sunsynk inverter. The Sunsynk inverter, this is a 12 kilowatt 3-phase. The chassis is the same as the other Sunsynk. The Days and the Sunsinks, they pretty much the same machine. I don't know about the internals, whether they share the same internals, but I know that the firmware is different. We'll take a look at that now, but let's start here at the batteries. So these are LBSA, lithium battery SA batteries. They are 5.3 kilowatt hours each. So altogether just over 15, about 15.6 kilowatt hours of battery storage, and they have the similar LCD display as the previous one. They display the cycle number, the capacity is there, and what the current capacity is. So right now we are about 60% charged, and that's because the morning peak demand was quite high, so the batteries haven't had an opportunity to charge. Whatever we generated was basically consumed in the house itself. Okay, moving to here. So these are gene molders. One is a fuse and one is a disconnect. We reused some of the switch gear from the last time. These are the surge arresters. These are the breakers for the two strings, the two solar panel strings. This is a 18-way dB, and we've got three-phase changeover and three-phase breakers here and isolators. This is an AC dB. We have an earth leakage here. We have a 10 amp breaker, and we have a 6 amp breaker, and this is a contactor. And what the contactor does is it is now energized. So a contactor is effectively a relay. It's energized and it's got a little red pilot light there. What happens is that when there's a power failure, these two breakers are supplying the two dwellings electricity via backup plug socket. And the one, sorry, this is a 16 amp breaker. So the one breaker is 16 amp and one is 6 amp, and the one that 6 amp is just to prevent an overload. We don't want to overload the inverter. So 6 amps will allow about 1000 watts roughly of electricity, and the contactor will automatically send power to those breakers and then to the other two dwellings at that plug point automatically. So that's the advantage of having the contactor there. Let's come to the inverter now. In the DAE setup that we reviewed a couple of months ago, that was an 8 kilowatt setup, and we also mentioned the fans. And as you can hear, the fans are on now, because if you take a look here, so right now we are producing 9629 watts. From MPPT2 we're looking at 6000 watts, and MPPT1 3600 watts. The battery is at 56% and it is charging. The minus sign indicates that it's charging, so it's sending about 960 watts there. This is ESCOM now. There's a ESCOM grid. This is a icon for the CT coil, and we're only pulling 28 watts from ESCOM. This is configurable from the inverter settings. So depending on the demand, if there's no demand, you'll always find that it is pulling about 20 watts. So it always pulls about 20 watts, just so that it is aware that the grid is still connected. We did not connect anything on the auxiliary load. The entire house is on the UPS except the instant water heater and the geyser. So the geyser has been tripping. Look at the fault code. So since we installed it, the geyser here, the AC overcurrent fault and the AC overload fault, that was caused by having the geyser on and a couple of other loads, and then that just caused an overload. But if you manage it wisely, whereby you don't have any heavy loads and you run the geyser, then the inverter is capable of running that geyser. It's a 4000 watt element, so it does pull a lot of power. So it does have a wind turbine input as well, so you can attach a wind turbine. So we've got a grid here. This is showing you how much of power you're generating from your solar. This is the load, and the load is quite high now because I think the geyser is on. So the geyser is on and we connected to the grid. So what's happening is that the solar is sending all of its power to the load, the AC load, and maybe one of the other dwellings are pulling some power as well. And this is just a chart that shows you how much of power went into the battery. So right now, for today, we charge the battery using 6 kilowatt hours and we use 4.7 kilowatt hours. The state of charge is 56%. Solar produced 34.5 so far kilowatt hours, and it's 20 past 1 in the afternoon. And this is how much we bought from the grid, from ESCOM. We bought 17.3 kilowatt hours. That was the morning demand, and a little bit from overnight as well. If you click on the battery icon, then it shows you what your load is. It shows you your battery state of charge and what status the battery is in. The minus indicates that it is being charged. This is your grid power and the voltages and the amps, the current for each phase. And on your grid power, you've got string 1 and you've got string 2. So we got 6 kilowatts here and 3.6 kilowatts on that MPPT with your current as well. and the inverter power is what is being sent out for each phase altogether. Yeah, so on the first phase we're looking at 1.2 kilowatts, 4.3 kilowatts and 2.5 kilowatts, and the temperature here of the inverter inside on the AC side is 50 degrees. So the red indicates ESCOM, and it also tells you the voltage. Green indicates that your inverter is on, and it indicates your voltage as well. So we've almost got parity between ESCOM and what the inverter is producing. And then this was my idea. So the contactor was also my idea. And I've got my smart meter here, and if you take a look here, this smart meter must be connected to an ESCOM connected plug socket. So this socket is connected to ESCOM. If it's connected to the inverter socket, it's not going to work correctly. I had an issue with the ESCOM billing where this smart meter, it has an IoT device that is in the mini sub. So the smart meter itself has an identifier, and it is sending information to that IoT device, and that is how ESCOM is able to read your meter. ESCOM is running Oracle, I think it is. So all of that data goes into Oracle billing, and your invoice is generated, and based on your consumption they charge you. Now when I was asked to submit a reading manually, an agent from ESCOM called me and asked me to take pictures. I sent them pictures of everything here, all of those IDs, and they billed me on the cumulative total, which is this 101,000 number here, which includes what I consumed and what I produced, and my bill was about 4 times more than what it normally is. So it took me a while to resolve that, but that's why I got everything here now all in one place. So at any one point in time, if I see that I'm generating a whole lot of electricity, but this little flashing red light, this is directly proportional, this light, if it flashes very fast, then that indicates that you are drawing a lot of electricity from ESCOM. And I'm not talking about this one here. I'm talking about the light here on the top, which has stopped flashing now. Okay, I think we covered everything here, and let's take a look at now the DB board inside. Okay, if you remember in a previous video when I described and I demonstrated the whole setup here, we had a surface mounted distribution board here, and that took care of the backup power, the backup outlet. Now we've done away with that. We also had a NOS cable here. NOS is it's a shielded cable, and according to regulation, a NOS cable, because it's shielded, it can be surface mounted. But now, just to make everything look nice and neat and aesthetically pleasing, it's all within a trunking, and we've got 6mm square cable coming in for the 3 phases from the inverter, and they come into this breaker, and this is the earth leakage. It's now a 3-phase earth leakage. This is a main feed from ESCOM, and this is the ESCOM feed that goes into the inverter, and this is just a separate single phase earth leakage for the geyser. So the geyser and the instant water heater are feeding directly from ESCOM, so we have a separate earth leakage for that. So the good thing is that now we don't have any surface wires, we don't have any surface mounted DB, we have the timer for the geyser here, and this changeover we retained. We repurposed it just to change over the geyser if required. So if we turn the geyser up, then it'll switch on to inverter power, and that's worst case scenario if we need to heat the water in the geyser, just in case we do have the capability to heat it via solar PV for whatever reason. Let's show you the Sunsynk app, and then we can conclude the video. Okay, here we are in the Sunsynk app, and if I pull down on my screen, it updates every 5 minutes, and you can see that I'm generating 9,664 watts. The efficiency of my solar panels is 74.3%. My energy produced in total today is 36.1, and my energy that I've produced so far since installation is 532 kilowatt hours. If I click on that, it gives me a summary view of what is actually going on from a panel perspective and my battery perspective, what my load is in the house or on the entire property, and what I'm pulling from ESCOM. And there's a whole bunch of charts here at the bottom that you can go and view historically as well. There's a summary of the weather as well, and this is nice if you want to plan ahead. So if you want to look at what the weather forecast is for the upcoming days and manage your energy demand and usage, you can do that. And then at the bottom there's some statistics of what we've saved in terms of carbon dioxide and sulfur dioxide and so on and so forth. If we go into the equipment and click on that, this gives you details into your input. So this tells you per MPPT what is the current, what is the output, power output, and there's a chart as well of your solar generation as well as your current and your voltage. If you look at the battery is at 58%, gives you a chart of your state of charge as well, the voltage and your current. We peaked at today about 185 amps. That was at 6:28 in the morning, and there's charts here as well for charge and discharge, which is almost equal, because remember we're not depleting the batteries completely. If we look at grid just gives you a summary of how much we imported. So today we imported 17.3, and in total since installation we purchased 320 kilowatt hours so far. And it also tells you what your output is per output on each phase, the load. And this is what I was talking about. So if we look at yesterday, because we had load shedding this morning, if we look at yesterday, look at this demand here. At 4 o'clock in the morning, the demand was 4,300 watt. If we move a bit later than that, at 4:58, 8,293 watt, and then we peaked at 5:33 at 11 kilowatt. So the demand in the morning between 4 a.m. and at by 8:45 the sun is pretty strong already. So between 4 a.m. and 8 we are buying about 50% of our power for that day. That is it. And then on your events you can also see any faults. So I think I did see faults here. Let me just look for it. Yeah, event. If you go to event here, and if I look at last 7 days, no. Okay, so there's no faults, but if there are any faults then they will be displayed here. Okay, in this video we covered our solar panel setup, the inverter setup, the battery setup, as well as the distribution board setup and the changes that we made. You can have a look at our previous videos to see our journey from having a UPS to solar power, single phase inverter, and now a 3-phase inverter which is off-grid, 80% or 85% off-grid. And I hope that you enjoyed this video. There's a wealth of information, a wealth of our experience that we've shared. Till next time, thank you.